Okay, so this question is a combination of scientific notation and distance, speed and time. So the first one is just scientific notation. We to write 868 million in the form a by 10 to the n, where n is an element of an integer. So z is a symbol for an integer, which is any positive or negative whole number. And a lies between 1 and 10. So the first thing that we have to do is we have to write out 868 million in numbers. So it's 868 and there are 6 zeros in a million. And at the end, we're just going to put in our imaginary decimal place. So we want this number to be between 1 and 10. So this decimal place needs to be moved 1, 2, 3, 4, 5, 6, 7, 8. It needs to move to here in order for the number to be between 1 and 10. So we end up with 8.68 by 10 to the power of 8 because the decimal point moved 1, 2, 3, 4, 5, 6, 7, 8 places to the right. Okay, so the next question. During the Apollo 11 mission, it took approximately 1.3 seconds for a radio signal to travel 380,000 kilometers. So we want to find the average speed of the radio signal in kilometers per minute. Give your answer in the form a by 10 to the n, where again, n is an element of an integer and a is between 1 and 10. So straight away, when we see average speed, we are thinking about Dad's silly triangle. Okay, so just write that in the top corner. And we also know that if we're looking for the speed, we cover what we're looking for and we're left then with what we need to use in our formula. So speed is equal to distance divided by time. So we'll write that over here as well. Speed is equal to distance divided by time. Okay, so our distance here is 380,000 kilometers, but I'm going to write that in scientific notation. So 380,000 kilometers will be 3.8 multiplied by 10 to the power of 1, 2, 3, 4, 5, 10 to the power of 5 over. Now, this is where it can be tricky. We want to know our time. So we want to find the average speed in kilometers per minute, but our time here is in seconds. So we need to convert the 1.3 seconds into minutes. And to do that, we need to divide 1.3 by 60 because there are 60 seconds in 1 minute, and that will give us 0.217 minutes. So now I can divide by 0.217 and I now have my top line, my distance in kilometers, which it should be, and my bottom line should be in minutes. So now I can just divide both of them and I end up getting 1.75 multiplied by 10 to the power of 7. Okay, so the last part of the question then asks us to find how many minutes it would take a radio signal to travel 868 million kilometers. So again, minutes, distance, we know that we've got the speed of the radio signal here. So again, we want to write out our formula. So distance over speed by time. This time, we want to find out how many minutes. So we're looking for the time. So we're going to cross off the T and we're left with time equals distance divided by speed. So our distance is 868 million, which we already worked out previously that is 868 million, in scientific notation, 8.68 by 10 to the power of 8. So our distance is 8.68 by 10 to the power of 8. We're dividing that by the speed. It's the radio signal that we're talking about. In our previous question, we got the speed of the radio signal, which is 1.75 by 10 to the power of 7. So that's what I'm dividing it by. And our answer is 49.6 minutes.